logarithmic functions, f of x equals to log base a of x. So once again, this is f of x equals to log base a of x. Let's take a look at the graph. We have f of x equals to log of x. Do you see that in this red function, I did not mention the base, right? So when the base is not specified, by default, the base is equals to 10. And then I use a decimal to create this graph, decimal DESMOS. So go look it up on Google. You can download this from App Store or Play Store. It's completely free. So in decimal, I type y equals to, you don't really have to type f of x. Just type y equals to log of x, and then they will show you the graph. So the graph looks like that. And then, what do we see here? So first of all, this is an increasing function. So log of x is an increasing function. Based on the graph, there is a vertical asymptote at the y-axis. So at the y-axis, this is a vertical asymptote as x approaches to 0 from the right, y approaches to negative infinity. So as x approaches to 0 from the right hand side, do you see this piece of the curve? So as x approaches to 0 from the right hand side, and then you can see that y goes all the way down to negative infinity. So the vertical asymptote is x equals to 0. If you want to sketch the graph of the vertical asymptote in decimal, you can start another line. Just type x equals to 0. By default, they give you a solid line. So if you want to change that to a dashed line or a dotted line, you have to click the gear icon, and then they will let you modify what kind of line do you want, just so you can change that from the solid line to a dash line. And then how do I get those points? So to get those points, you have to hit the clear icon, not the clear icon, you have to hit the gear icon, and then you hit the graph icon. So once you hit the graph icon, you can select some x value. So in my picture, I selected x equals to 0.25, x equals to 0.5, x equals to 1, x equals to 2, and x equals to 3. Every time you put an x value into the table, they will give you the corresponding y value. The decimal will calculate the corresponding y value for you. And then they will show you the point on the graph as well. So when you use the pointer to click on the point, they will display the coordinate of each point. So I took a screenshot and then put that over to my notes. That is how I create my graphs. And then the domain is x from 0 to positive infinity. So we do not have any negative x because there is a wall, we can say a vertical asymptote at x equals to 0. So there is nothing on the right hand side of the y-axis. So the domain is x goes from 0, not including 0, because when x equals to 0, we have a vertical asymptote. So from 0 and then all the way down to positive infinity. And then the range y can be negative, y can be positive. So that's why for the range, y is from negative infinity all the way up to positive infinity. So that is the graph of log of x. So this is log of x. The full name for log of x is, we call this a common logarithm, because later on we have a natural logarithm. So log of x, when the base is not specified, by default the base is equals to 10. Can we specify the base? You can specify the base on decimal. So let's say I want to graph f of x equals to log base 2. So this time I type a base 2. I think in order to type a base 2, you have to type underscore. Yes, once you type underscore, they will let you specify the base on decimal. So log base 2 of x, and then this is f of x equals to 2 to the x, and then y equals to x. So why do I have to graph these three functions? This is because log is the inverse function of this exponential function 2 to the x, and this exponential function is the inverse function of this common logarithm. We will see why in a minute. So the domain of log base 2 of x is from 0 to positive infinity. We have to take a look at the picture. So the red graph, which is right over here, so this is the graph of log base 2 of x, and then the blue graph right here, this is the graph of the exponential function 2 to the x. So what is the domain of the log base 2? So the domain of log base 2, remember, for common logarithm, the log, there is a vertical asymptote at x equals to 0. So therefore, the domain of log is from 0 all the way to positive infinity. So from 0 all the way to positive infinity. And then that is equals to the range of the exponential function. I am looking at this line. The domain of log 0 to infinity is equals to the range of 2 to the x. Is this true? The range of 2 to the x is from 0 and then all the way up. Alright, so the range of 2 to the x is y greater than 0. Because 0 to positive infinity, that means x greater than 0, right? So x greater than 0, when you talk about the range, you cannot use x anymore. You have to use y. So therefore, on the other side, 2 to the x, instead of saying x greater than 0, you have to say y greater than 0. Let's use the picture to confirm my answer. Look at the domain of 2 to the x. So this one is completely above the x-axis, which means y is greater than 0. Then you might ask me, hey, should we put an equal right here? The answer is no, you cannot use an equal because for exponential function, there is a horizontal asymptote at x equals to 0. Right? So that's why you cannot put an equal in the inequality. It must be y greater than 0. Okay. Next line, the range of log is from negative infinity to positive infinity. So the y, we have the curve. We have a piece of curve below the x-axis and then a piece above the x-axis and then on the x-axis as well. So y can be negative, positive, and 0. And then therefore, the range of log base 2 is from negative infinity to positive infinity. So since the range of y, I should say the range of f is equals to the domain of f inverse. So let's pause right here. Do you still remember this from the inverse function lesson? The domain of f is equals to the range of f inverse. The range of f is equals to the domain of f inverse. So the range of f is equals to the domain of f inverse, which is from negative infinity to positive infinity, because looking at the exponential function, the blue curve, x can be negative, positive, and 0. So the range of log is equals to the domain of the exponential function, and then y equals to x is a reflection. Now, what do I mean by y equals to x is a reflection? Let's take a look. When x is equals to 1, y is equals to 0. This is a point in the log, right? So this is a point in the log. And then on the other side, you have a 0, 1. So we remember back in the inverse function, I treat y equals to x as a mirror. So let's say you are standing in front of a mirror. Take out your left hand. So take out your left hand, use your index finger to point at the mirror. Do we agree that your image is pointing at the mirror as well? Also, do we agree that if you take a different perspective, so instead of considering yourself, what if you are the reflection? So let's say you are the reflection inside the mirror. Do we agree that you are actually holding up your right hand? So in other words, your left hand, you are using your left hand, you are using your left index finger to point at the mirror. And in the meantime, your reflection is using the right hand to point at the mirror. So using the mirror, your left hand is the right hand of your reflection. So the mirror is like y equals to x, that allows you to exchange the x. I should say exchange or swap the x and y coordinate. So in f of x, we have 1, 0. Then in inverse, we swap the x and y. So let's take a look at one more point. We have 2, 1, 1, 2. We swap the x and y. Let's do one more. 3, 1.5, and then on the other hand, we have 1.5, 3. The y equals to x allows you to interchange or swap the x and y coordinate. So that's why we also need to consider y equals to x. Now, Moving on to logarithmic form and exponential form, I mentioned the logarithmic function again, y equals to log base a of x. This is in logarithmic form because you see log, right? Logarithmic form. And then what a to the y power equals to x. This is called exponential form. How do we get that? So let's say we have log base 5 of 25. This is equals to 2. Do you know why? Because base 5 raised to the second power. So here is the process. You write a base 5 right here. Raised to second power equals to 25. So the 5 squared equals to 25 is called exponential form. And then the log is called logarithmic form. So you should be able to like go back and forth between logarithmic and exponential form. Now, of course, we have to do some exercise. Now, in the first column, I gave you two logarithmic form. I want you to write the exponential form. So the first problem is you have base 4 of 16 equals to 2. The correct way to read this is log base 4 of 16 equals to 2. So the exponential form is you write the base, and then you look over to the other side of the equal, pick up the number, put that in the exponent, equals to 16. This is true, right? 4 squared is equals to 16. The other one, log base 8 of 64 equals to negative 2. So 8 to the negative 2 power equals to 64. Did I say 8 to the negative 2? Why do I put a negative 2? This is supposed to be a positive 2. Because a squared is equals to 64, a squared is equals to 64. So that is supposed to be a positive. Do you know that why is this a mistake? So I was having a negative 2 right here. So this is clearly a mistake. I think I make a minor mistake when I copy stuff from my notes over to my iPad. So do you see why this is a mistake? Log base 8 of 64 cannot be equals to negative 2. Do you know why? The reason is 8 to the negative 2 is not equals to 64. So how is there another way to modify the problem? Of course, I can do the modification right now. So for that, I am going to write a different problem. I am going to write this. Log base 8. How about this? 1 over 64, that is equals to negative 2. And then I should erase that. And then this is 8 to the negative 2 power equals to 1 over 64. Because 8 to the negative 2 power is 1 over a squared, and then 8 times 8 is equals to 64. So that is the correct way to fix the problem. I should say they are both correct. They are both correct. Log base 8, 64 is equals to 8 to the second power equals to 64. This is absolutely right. I add another problem. Log base 8, 1 over 64 equals to negative 2. A to the negative 2 power is equals to 1 over 64. How about from exponential form back to logarithmic form? So from exponential back to logarithmic, so this is 4 to the 3 over 2 power equals to 8. So the half in the exponent, that is a square root. The square root of 4 is equals to 2. 2 raised to the third power is equals to 8. And then for exponential form, so here is how we do it. So we write log first, and then what is the base? The base is 4, right? So you put the 4 in here, and then you look over to the other side, pick up the 8. You can put the 8 in parentheses, equals to 3 over 2. So that is logarithmic form. When you go from logarithmic back to exponential, you write the 4, pick up the exponent, and then let that equals to 8. And then the next problem, we have log. What is the base? The base is 3. And then the negative 4, I'm going to put the negative 4 to the other side, and then equals to 1 over 81. Right? And then the last one, 7 to the 0 power is equals to 1. So we have log base 7 equals to 0. And then this is a 1. So log 7 to the 0 power, that is equals to 1. So let's go over the properties of logarithm. We have 4 properties. The first property is log base a of 1 equals to 0 in exponential form. a raised to the 0 power is equals to 1. So this is a base a raised to the 0 power equals to 1. Log base a of a is equals to 1. So a raised to the first power is equals to a. I color coded the base for you. And then the next one, log base a to the x, that is equals to x. And then I color coded the x for you. Also, a raised to the log base a of x, that is equals to x. This is called the inverse properties. And then the last one, the one-to-one properties, if log base a of x equals to log base a of y, notice they have the same base a and base a, that x is equals to y. This is the one-to-one properties. They are not that hard to use. So the first problem, we are going to practice a few problems. I have log base phi of phi. What is that equal to? Then you should ask yourself, this is what you should do in your mind. Phi raised to the what power is equals to phi? The answer is 1, right? Phi raised to the first power is equals to phi. And then log 7 of 1 is equals to what? So 7 raised to the what power is equals to 1? The answer is 0. And then the next one, we will be using the inverse property, the one right over here. So we have base a and then a square. As a result, that is equals to 2. And then this one, this is a base a, this is a base a, so the whole thing is equals to 10. And then the last one, we have log x minus 3 equals to log of a. I did not mention the base, then what is the base then? If the base is not specified, then by default, the base is equals to 10 on both sides. So I can just say x minus 3 equals to a, that x is equals to a plus 3, which is equals to 11. All right, so that is the end of the introduction to common logarithm. F of x equals to log of x. If you like the way I introduce common logarithm, give my video a thumbs up, give my channel a subscribe, and I will meet you all in the next video for more math content. Signing out.